Good morning, students. Today we are going to deal the unit number 3. This is video number 6, continuation of the last week class. And this lesson we are going to see the first one, objectives, to learn about halogen group elements, preparation and properties of hydrochloric acid, to learn about inter-halogen compounds, to study the properties and uses of inert gases. So all these headings we are going to complete in this particular video class. The first one, halogen group, chlorine. So how it occurs, the occurrence. It is present in combined form as they are highly reactive. Chlorine is a highly reactive compound, therefore it is combined form only it is present. The main source of fluorine is fluorspar or fluorite. The fluorspar or fluorite are the ores of fluorine from which fluorine can be obtained. The other ores are cryolite and fluorapatite. Cryolite and fluorapatite. But for chlorine, the main source is sodium chloride, that is common salt, which is from seawater, which we can obtain from seawater. So for fluorine and chlorine, they have given the ores and the main source of preparation. The next, let us see the physical properties of the group 7 elements. So first of all, you should know what are the group 7 elements: fluorine, chlorine, bromine, iodine, astatine. See their atomic number: 9, 17, 35, 53 and 85. If see their physical state, fluorine and chlorine, they are gases. Bromine is a liquid, whereas iodine and astatine are in solid phase only. So the phase goes on, increases from gas, then to liquid, then to solid. Please remember this one also. Then some of the isotopes of the compounds are given, especially chlorine. In 11th standard we have seen it has mass number 35 and mass number 37. So like that, for astatine also you have 210 and 211. So these are all the isotopes they have given, and the remaining atomic mass, electronic configuration. Electronic configuration, we know that this is nearer to the inert gas, one group earlier. Therefore what happens, the final octet structure, instead of that it is one electron less. For example, helium, it is 2s2 only, whereas for fluorine you have 2s2 and 2p5. It needs only one electron to have the complete octet structure. So similarly all the things, 3s2 3p5, 4s2 4p5, 5s2 5p5, like that it goes on for argon, krypton, xenon, and all these things will come. So this is the electronic configuration of fluorine, chlorine, bromine, iodine, which is one electron less than the inert gas structures. Then atomic structure, density, melting point and boiling points are given. It goes on, increases from fluorine to astatine. Both melting point and boiling points are increasing. The next one is the preparation of chlorine. Chlorine is prepared by the action of concentrated sulfuric acid on chlorides in the presence of manganese dioxide, that is MnO2. See the equation: 4NaCl, that is sodium chloride, plus MnO2, manganese dioxide, plus con sulfuric acid concentrated, that is 4H2SO4, gives chlorine gas, Cl2, plus MnCl2 plus 4NaHSO4 sodium bisulfate plus 2 water molecules. So this is the equation for the preparation of chlorine. The next, it can also be prepared by oxidizing hydrochloric acid using various oxidizing agents, so such as manganese dioxide, lead dioxide, potassium permanganate and potassium dichromate. So 4 oxidizing agents they have given. In all these oxidizing agents, they react with HCl, hydrochloric acid, and chlorine gas is liberated. Let us see the first equation. PbO2 plus 4HCl gives PbCl2 plus 2H2O plus chlorine gas Cl2. Similarly, manganese dioxide, MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Similarly, potassium permanganate and potassium dichromate, in all these cases chlorine gas is prepared. When bleaching powder is treated with mineral acids, chlorine is also liberated, which we have seen in our houses also. When bleaching powder is treated, chlorine gas is liberated. First equation, CaOCl2, that is bleaching powder, plus 2HCl gives CaCl2 plus water plus chlorine gas Cl2. So in this way also chlorine can also be prepared. The next one is manufacture of chlorine. So how chlorine is prepared in large quantities, that is what you call manufacturing. The first process, electrolysis of brine. When solution of brine, that is solution of NaCl, common salt, is electrolyzed, Na plus and Cl minus ions are formed. Na plus ion reacts with OH minus ions of water and forms sodium hydroxide. Hydrogen and chlorine gases are liberated at anode and cathode. Let us see the equation. NaCl gives Na plus ion and Cl minus ion. Water molecule dissociates into H plus ion and OH minus ion. And then NaOH ions gives NaOH solution. So what is the reaction at cathode? In cathode, H plus ions and electron combine together and forms hydrogen atom. So 2 hydrogen atoms combine together and forms a hydrogen molecule. Similarly, at anode what happens? Anode is positive. Therefore, there the chloride ion, Cl minus ion, dissociates into Cl and electron. And 2 Cl atoms combine together and form Cl2 molecule. So this is the reaction which takes place at anode and cathode. The next manufacturing method is Decaun's process. In Decaun's process, a mixture of air and hydrochloric acid is passed through a chamber containing number of shelves and pumice stones soaked in cuprous chloride in the presence of Cu2Cl2, that is cuprous chloride. Hot gas about 723 Kelvin is passed through a jacket that surrounds the chamber. So in this method we can prepare chlorine. See the equation, 4HCl plus oxygen, the temperature is 400 degrees Celsius, and in the presence of cuprous chloride Cu2Cl2 gives 2 molecules of water plus chlorine gas. So in this way, Decaun's process, chlorine is manufactured. And this method dilute and is employed for manufacture of bleaching powder. The chlorine obtained is dilute. The catalyzed reaction is given below. See the reaction down, Ca2Cl2 plus O2 gives 2Cu2OCl2, that is cuprous oxychloride. This cuprous oxychloride, when again combines with 2HCl, gives cupric chloride, that is CuCl2. And this cupric chloride gives cuprous chloride Cu2Cl2 plus chlorine gas. which is the preparation method according to Decaun's process. The next is physical properties of chlorine. Chlorine is a greenish yellow gas with pungent smelling, that is irritating smell. Inhaling large quantities of chlorine could be fatal, that is it leads to death also. It is heavier than air. How much heavier? It is 2.5 times heavier than air. It is easily soluble in water and known as, when it is dissolved in water, that water is known as chlorine water. It can be converted into liquid and solid. The solid melting point is 102 degrees Celsius. Now let us see the chemical properties of chlorine. It reacts with metals and nonmetals to give the corresponding chlorides. For example, chlorine reacts with Na, sodium, it gives sodium chloride. Chlorine reacts with iron, Fe, it gives FeCl3. When it reacts with aluminium, Al, it gives AlCl3. When chlorine reacts with copper, it gives copper chloride, CuCl2. And then chlorine reacts with hydrogen, H2, it gives 2HCl, hydrogen chloride. So these are all the chemical properties. And then action with the metals and nonmetals. The action of chlorine with the metals and nonmetals. Let us see the first one, nonmetals. When it is treated with the boron, it gives BCl3. When it reacts with sulfur, it gives disulfur dichloride, that is S2Cl2. And the next, when it reacts with the phosphorus, P4, it gives PCl3, phosphorus trichloride. And then chlorine reacts with arsenic, it gives arsenic chloride, AsCl3. When it reacts with tin, Sb, it gives SbCl3. So like this, it reacts with metals and nonmetals. Then affinity for hydrogen. Affinity for hydrogen, when burnt with turpentine, chlorine, when burnt with turpentine, it forms carbon and hydrogen chloride. See the equation down. For turpentine, the formula given is C10H16. So it is an hydrocarbon. Only carbon and hydrogen are present. Therefore, it is an hydrocarbon. C10H16 turpentine plus 8 chlorine Cl2 gives 10C, 10 carbon plus 16 HCl, hydrogen chloride. Another reaction, chlorine reacts with water and it forms O2 and HCl. So it changes chlorine into hydrogen chloride. It converts chlorine into hydrogen chloride when reacted with water. The next, when the chlorine is reacted with ammonia, excess ammonia. So let us see what are all the products. So the first one, 2NH3, that is ammonia plus 3Cl2 gives N2 plus 6HCl, nitrogen and HCl. When this HCl reacts with 6 ammonia, it forms ammonium chloride, NH4Cl, ammonium chloride. You must pronounce it as ammonium chloride, not ammonia chloride. So the overall reaction, ammonium 8 plus 3Cl2 gives N2 plus 6NH4Cl, ammonium chloride. Similarly with the excess chlorine, NH3 plus Cl2 gives NCl3 plus 3HCl. Let us see the overall reaction. Ammonia plus 3Cl2 gives NCl3 plus 3NH4Cl, ammonium chloride. So this is the overall reaction when excess of chlorine is there. The next, liberates bromine and chlorine. When it reacts with KBr and Ki, chlorine reacts with potassium bromide and potassium iodide, it liberates bromine gas and iodine gas. See the second and third equation. Chlorine plus 2 KBr gives KCl plus Br2. And similarly, the next one, Cl2 plus 2 Ki gives 2 KCl plus iodine gas I2. Then reaction with the alkali. So chlorine reacts with cold dilute alkali to give chloride. It gives corresponding chloride and hypochlorite. Let us see the example. When chlorine reacts with water, it gives HCl, hydrogen chloride, and then plus HOCl, hypochlorous acid. The next one, HCl plus NaOH, sodium hydroxide. It gives NaCl, sodium chloride, plus water. Then HOCl plus NaOH gives NaOCl, sodium hypochlorite, plus water. So when you see the overall reaction for all the three, see the fourth equation, Cl2 plus 2 NaOH gives NaOCl, that is sodium hypochlorite plus sodium chloride plus water. And then again there are so many reactions with the alkali. Let us see. Chlorine plus water gives HCl plus HOCl. See the equations which you have seen now. Multiply all these equations with 3, and finally if you get that overall reaction, the final equation you can see 3Cl2 plus 6 NaOH gives NaClO3 plus 5 NaCl plus 3 H2O, the overall reaction. Multiply all the equations with 3 and add, and then you finally will getting this one. And the next one, oxidizing and bleaching action of chlorine. So chlorine is a strong oxidizing agent, and it is also a bleaching agent because of the nascent oxygen it produces. Nascent oxygen means atomic oxygen. See the first equation, water plus Cl2 gives HCl plus HOCl, and the second equation, HOCl gives HCl, hydrogen chloride, plus one nascent oxygen, O. Simply O, it's not O2, it's O. This is what you call nascent oxygen. This nascent oxygen is the reason for its bleaching action. So bleaching, removing the color. The reason is it gives an atomic oxygen, that is nascent oxygen. There are so many other reactions were also given. The bleaching of chlorine is a permanent reaction. It oxidizes ferrous salts to ferric, sulfides to sulfates, hydrogen sulfide to sulfur. For all these things we have given the equations down one by one. So it changes, oxidizes ferrous salts to ferric, sulfides to sulfates, hydrogen sulfide to sulfur. So these are all the reactions which represent this point. Next, preparation of bleaching powder, very important question. So bleaching powder is produced by passing chlorine gas through dry slacked lime. Slacked lime means calcium hydroxide. CaOH twice is known as slacked lime. Please note it down. It may even come in the objective type questions. Plus CaOH twice plus Cl2 gives CaOCl2. This is bleaching powder. CaOCl2 is bleaching powder plus water molecule. So this is the preparation of bleaching powder. The next one, displacement redox reactions. So reduction reactions. Chlorine displaces bromine from bromides and iodine from iodide salts, which I have seen just earlier. Again it is coming now. Chlorine plus KBr gives KCl plus Br2 gas. Similarly, Ki gives iodine gas. The next subheading is formation of addition compounds. Chlorine forms addition products with sulfur dioxide SO2, carbon monoxide CO, and ethylene C2H4, and it forms substituted products with alkanes and arenes. See the first example. Chlorine combines with the SO2 gives SO2Cl2, sulfuryl chloride, and then carbon monoxide plus Cl2 gives COCl2, carbonyl chloride. And the next, if you see ethylene, C2H4 is ethylene, plus Cl2 gives C2H4Cl2, ethylene dichloride. Ethylene dichloride. These are all known as addition compounds because the two reactants combine together and forms the product. The next, methane plus chlorine gives methyl chloride plus HCl, and then benzene plus chlorine in the presence of FeCl3 gives chlorobenzene, that is C6H5Cl plus HCl. And finally, we are going to see the uses of chlorine. So the first use, it is used in the purification of drinking water. You know that in the houses and all, when they pass chlorine, we say chlorine gas, the chlorine smell is coming in the water. So this is used for purification of drinking water. And then bleaching action of cotton textiles, paper and rayon. In all these things, chlorine is also used. And finally, important, extraction of gold and platinum, we use chlorine gas also. So